My name is Mark Wilson, and I have a particular CAD program here called the Libre, which is a computer-designed parametric modelling package. At the moment, just to show you what this can do, I've done a few videos on this, but this one in particular is a project I'm working on. And I'm just going to click on the main assembly here and boot that up and just explain to you what I'm going to check here. And this is the clock that I'm designing at the moment. It is it's the original clock, and that this part around here and all this mechanism here is basically a John Wilding regulator clock mechanism, and I've done it exactly as it is designed. But on the bottom here on this, the hour hand wheel comes off. That's the hour hand wheel, so there'll be an arbor coming out here driving the hour hand. Off this particular one here, there'll be the minute hand, and this one here where the escape is will be the second hand. But on this, I've added an extra part to this clock, and there's a few more things going on here. So I want to have a sidereal train built into this clock. So not only does it give the on the hour hand going around here, there'll be a small dial about here somewhere showing the regular hours. It'll also have a takeoff sort of gear that drives this train here. Now, sidereal time is 4 minutes and 4 seconds less than 24 hours. And the reason for that is, as the Earth rotates to the Sun, one full revolution is 24 hours. But the position of the Earth also changes as it rotates, because it's also in orbit around the Sun. So when it comes back to the centre of the Sun again, which is our standard 24 hours, the Earth's in a slightly different position because it's in orbit around the Sun, and therefore that's our standard time. But if you do the Earth rotation to a star that we're not in orbit around, it is 4 minutes and 4 seconds less than the regular 24 hours, and that's called sidereal time. Now, this particular train here that I've built in here has a number of wheels driving through here, connecting through here, and then down to a shaft and a bevel gear at the end of it, and this will then go on to drive a sidereal sky chart, like a night sky chart, further down the clock. Now, this train here, I'll just close this down, and we'll close that window, and I'll just have a look at this train, this sidereal train in particular. And this is the same train here. I'll double click on that. And this is the sidereal train again, but just on it separately. Now, there is, according to my research, to come up with the correct ratio, we need a 49-tooth wheel driving a 79-tooth wheel, which is that one there, keyed or in unison with an 82-tooth wheel, which is that one there, driving a 51-tooth wheel. And you can see here that that's exactly what I've got here. And not only that, we can also, because we're using a CAD package that has mechanical linkages that you can hook up here, I can put the ratio of these particular wheels in, and I can grab this here and I can drive this wheel around here, and it will drive the other ones, and you can see the ratio happening there. Now, I'm going to put this, let's have a look at this. I want to check this train, and I put this up, when I first put this in I had the train round the wrong way, and I worked out what was going on. So we'll just leave that front on here. You'll see here that I have a tiny little dot here, there, and I'll just go right in. There's a little hole through there, and down here we have another little hole there. Now I've already cranked this around a bunch of times to check this, but what I should see in this, as I rotate this, which is the hour hand wheel here, so that little shaft will come through here, is that as I crank this around clockwise, this will also go around clockwise, but that little dot there will slowly advance to the left, or no, retard to the left slightly slower, the 4 minutes and 4 seconds over time. So we'll just go and view that again, and we'll go in a little bit closer, and let's see if what I say is correct and prove whether or not this train is going to work. So we'll just grab this wheel here, and as I rotate this clockwise, we should see that's 1, 2, that will be 4 minutes and 4 seconds less than, and we should see, we don't really see much of a change in the bottom there because it's such a small amount on an hour hand wheel. But as we keep rotating, 1, 2, we should see 1, 2, we should see this little pip mark here slowly retarding to the left as this runs. So we'll just keep going and just prove to whether or not this is correct. We'll just do a whole bunch of turns here. Okay, there's a few there, and as we come up here back to top dead center, we'll have a look here, and of course my little hole there is slowly creeping, retarding to the left, the equivalent of 4 minutes and 4 seconds per 24-hour day. So we've proved that this particular ratio is correct. Now, what that's going to do in the end, I'll just close that down. I'll close that. I'm going to click on this one here, which is the star chart assembly. We'll put that in isometric. This is the star chart assembly, or at least part thereof, and you see there's a shaft coming down through here. There is a disc being driven by a bevel gear off the shaft, a drum, which is this one here, and another disc up the top. Now if I grab this, I've got this linked up mechanically as well, and that's all 1-to-1 ratios. If I grab this drum here and rotate that, you'll see that the two discs and the bevel gears all rotating. So if I go backwards and forwards with that drum there, you'll see I put a little dot there, you can see, and if I grab that disc there, you'll see that they rotate in unison. And on this particular disc here, this will be the southern hemisphere night sky. So in Australia we'll see the 2 pointers and the Southern Cross, and up from that will be the pole in the centre up to 45 degrees there, and so that would be the night sky from the pole to 45 degrees, and then there will be the night sky from 45 south to 45 north, and then the other 45 degrees to make up the full 180 degrees will be up the top here with the northern night sky, and of course, I'll just hit the home key there. There will be the Big Dipper, and of course the pole star will be in the centre there. So as this drives these little bevel gears here, you can see the bevel gears driving here. You'll see these discs slowly rotating, and of course they have to be on sidereal time, otherwise every 24 hours it would be 4 minutes and 4 seconds out of sync. So over the course of a few days it will slowly go out of whack, and the night sky won't line up with what you see on the night sky proper. And that's what I'm just building or designing at the moment. I'm Mark Wilson, and thanks for watching.